Now we're going to move into the how part of this. How is silviculture implemented and adjusted to meet different objectives? We delineate areas of forest land as forest stands for the purposes of management. A forest stand is a contiguous area of forest that's uniform enough in species composition, age class arrangement, and overall condition that it can be managed as a unit. Typically, a forest property has multiple stand types delineated by the ecological characteristics just mentioned. So silviculture is applied at the stand level. Stand by stand, foresters choose and implement silvicultural treatments to meet the objectives of the landowner. So just to reiterate, stands are commonly delineated by species composition, age structure. Other things may include the density of trees, or what we refer to as stocking, and often volume or value of timber present plays into the delineation of stands. Think about walking through the woods in western North Carolina. Hypothetically, you may begin in a sheltered cove dominated by yellow poplar and eastern hemlock that may range in age from 45 to 55 years old. This is an area where there's sufficient moisture and nutrients, generally productive site, resulting in a specific group of species. As you walk up through the cove and move onto an exposed ridge top, you may find scarlet oak, chestnut oak, pitch pine, maybe really dense mountain laurel in the understory. Maybe trees ranging in age from 80 to 110 years old, depending on past disturbances. Areas like these are, typically, dry, nutrient-poor, less productive sites. They would be delineated differently. So as a forester, regardless of the specific objectives we are seeking to accomplish, we would not likely manage these areas in the same way. They're inherently different. We would apply different silviculture depending on the goals. So the cove forest and the ridgetop forest would be delineated as different stands. Every stand may be broken down into different parts. The four primary parts that we will examine, working our way from the top down, are the canopy, the understory, the ground cover, and the forest floor. The canopy makes up the upper layer of green vegetation in a stand. These trees typically represent the most vegetative biomass within a forest, and as such utilize the greatest amount of site nutrients, including sunlight, water, soil nutrients, and space. The canopy itself may be further classified by crown class. The trees within the canopy can be classified by crown class. This is important because silviculture is often designed to either remove or retain certain trees based on that tree's particular crown class within the stand. A tree's crown consists of the foliage at the top of the tree, right? So the amount of live crown a tree has relative to its overall size provides an indication of its vigor and competitive ability. The larger and healthier the crown, typically the more vigorous the tree, the more likely that tree is to respond positively to an increase in site resources. Canopy trees are allocated to one of four crown classes based on the amount of sunlight their crowns are receiving. So they may be classified as dominant, codominant, intermediate, or suppressed trees. Sometimes we refer to suppressed trees as overtop trees as well. Keep in mind, this classification system applies only to the canopy trees, not trees in the understory. And so this slide here just illustrates the hypothetical position of trees representing the various crown classes in the canopy. On the slide, B's represent dominant trees, C represents codominant trees, I's are intermediate trees, S are suppressed trees or overtop trees, and the M, standing for mortality, those are trees that were once suppressed that are now dead. The wolf tree on the far right with the W on it, don't worry about that. Just what I want you to get a feel for is the various positions within the canopy of these different crown classes. By definition, the crowns of dominant trees extend above the rest of the canopy and receive full sunlight from above and from the sides as well. They tend to have the largest crowns. Codominant trees, slightly shorter, receive full sunlight on the tops of their crown and indirect sunlight on the sides. Intermediate trees are shorter. They receive a minimum amount of direct sunlight from above and no direct sunlight from the sides. Overtop trees or suppressed trees maintain really small crowns. They're set up below the main canopy level and they receive no direct sunlight. The second part of the forest stand is the understory, defined as a layer of woody vegetation, tree species below the main canopy. Young stands rarely have well-developed understories. As a stand gets older and natural disturbance results in the creation of some canopy gaps, understory vegetation becomes more prolific with the increase in available sunlight and growing space. So these are, they're typically shade-tolerant species. They get established under the main canopy, where they may or may not be eventually released with a disturbance. But shade-intolerant species may also establish within the understory, but that kind of relies on the creation of a relatively large canopy gap. Alright, the third part of the stand, the ground cover, consists of mostly of non-woody herbaceous material, herbaceous vegetation, and small seedlings. These species are important from a management perspective because they tend to give, they're important for a lot of reasons, but from a management perspective, they provide really solid clues regarding the productivity of a given stand. For example, species like ginseng, bloodroot, black cohosh, these are typically found throughout moist, nutrient-rich sites, productive sites. Bracken fern, blueberry, and huckleberry species, these are typically found throughout dry, acidic, nutrient-poor sites. Their presence or lack thereof give you an indication of the potential for the site in terms of what tree species will grow well, what the productive potential of the stand may be. The forest floor is the last part of the stand that we will delineate, and it consists of organic material above mineral soil. The term litter is applied to organic material that is still identifiable. Think about picking up a northern red oak leaf off the ground and still being able to recognize it as a northern red oak leaf. That is part of the litter, of the forest floor. The term duff refers to organic material that is decomposed to the extent that you can no longer recognize what it once was. Both litter and duff are included in the O soil horizon, the organic layer of the soil, and these two things, litter and duff, make up the forest floor.